Hello, and welcome to Palisade Corporation's webcast, Mega Project Cost and Schedule Estimates, A History of Denial, presented by Glenn Butts, Cost Analysis Officer of NASA's Kennedy Space Center. My name is Jameson Romeo Hall, and I will be your host today, and I'll be available to help answer WebEx technical questions by chat. If you experience technical difficulties joining this WebEx session, please dial 1-866-229-3239. At this time, all attendees are in a listen-only mode. Please note that as an attendee, you are part of a larger audience today. The attendee list is suppressed to maintain attendee privacy. We will be holding a Q&A session at the conclusion of today's presentation. You may ask an online question anytime throughout the presentation today by clicking on the question mark icon located on the floating toolbar in the bottom right side of your screen. I would also encourage you to visit our website and sign up for a free trial download of our software, including our lead products, At Risk, and the Decision Tool Suite. We invite you to sit back and relax and enjoy today's presentation. I would now like to introduce your presenter. One moment. Glenn, you have control.
Okay, I think we're up.
Looks good.
Go into the... Okay, as Jameson said, my name is Glenn Butts. I'm from Kennedy Space Center, but unfortunately I haven't had time to process the proper paperwork to get my presentation officially blessed by those that do those kinds of things. So I have to put the following disclaimer that all opinions expressed today in this presentation are my own and may not reflect those of NASA, and that's just a legal requirement that we are required to do. But I hope you find this worthwhile, and let's get started. I'm sure every one of you has seen headlines like this. I mean, basically, cost, overruns plague NASA, the DOD, everything. And, just stop and think about it. We can, NASA can put a spacecraft on Mars or an asteroid, but we can't come close to getting our budgets. Now, why is that? And we're not the only ones. I mean, look at this, the DOD, Olympic Village, the Big Dig, the Shuttle, the Alaskan Pipeline. Every major project, think about it, every single major project that has been done have had cost and schedule overruns. Now, do you really think that's a coincidence? I mean, it's not. There's a reason for that. Here's a recent example. This was just in this month's news. A brand new state-of-the-art Navy warship. Their original estimates were $220 million. But, of course, the military, they added requirements, and they needed them in a hurry to fight the piracy issue. So they expedited the construction. And so what happened? The cost more than doubled, went from $220 million to $460 million. And, of course, they had an excuse because of the new requirements. So that's excusable, right? Or is it? The Boeing 787 Dreamliner. Now, this was a radical new plan to build a revolutionary aircraft. And part of their plan was to outsource parts of this aircraft to manufacturing capability all over the world. And they started this project right after 9/11. They did not want to sink the tremendous amount of money into the project for tooling and dies and equipment, design to design the parts required for the aircraft. So they had a brilliant idea. And we're going to outsource this to lots of these suppliers all over the world. And we'll just issue a set of requirements, and we'll have them build it. And then we built a special aircraft this Dreamliner. That's a picture I took whenever I went out there recently to tour the Boeing's plant in Seattle. And it's a special aircraft. It's one of those cargo aircraft that the front of the section opens up so they can load in large sections of the fuselage. They use a tremendous amount of composite materials, and they use the composite materials, which are a new component relatively. They don't have a lot of experience making aircraft out of them, especially large aircraft. There have been some, DoD fighters and stuff aircraft made out of composites. And then they use new engine technology to reduce noise, and combined with the new engines and the composite materials that were really lightweight, this was promising tremendous fuel economy upgrades. But there was a problem. Their new plan didn't work. They had communications problems with suppliers. They had quality issues. They got the parts in and they didn't fit. The wrong length fasteners were used on some of the components. They had structural design issues. The initial test flight slipped by more than 2 years. Now, you can't tell me that this was a requirements change, because I'm sure Boeing didn't change the requirements, because why would it? They were the designer and the builder. So, why would their schedule slip? Why would their, costs go up? Last number I saw was like over $2 billion in cost increases. Why is that? They had 60 customers, cancel their orders because they needed aircraft and they couldn't wait on the delays. So they had to pay payments, concessions, rebates to airlines. They had to give money to suppliers. They actually purchased some of their suppliers outright so they could get a handle on the quality and, schedule issues. And then they also threw a lot of management, personnel at the project to get it on track and going. And basically the quote at the bottom of the page is, the initial plan outrun our ability to execute it. And this project may be excusable because this was a revolutionary new way of doing business. And I don't know how many times you've heard that in, proposals, is this is totally different. This has never been done before. And a lot of times the reason it hasn't been done before is because it wouldn't work, as this example proves. But what about the next case? The next case is another aircraft from Boeing, and this project started about 2 years after the 787 project. So they already had that project under their belt. You would think they would have learned some lessons. And this is not a new aircraft. This is not a major refurbishment. It is simply a variant of an existing 747 that's been in production for a long time. Basically, they're upgrading the wings to a slightly more efficient design. They're putting new engines that are a little quieter and more fuel efficient, and they're upgrading the cockpit, for some of the radar and some of the radar radio systems and communications issues. But they did not use composite materials. They used standard, run-of-the-mill manufacturing processes. But this project isn't working either. It's having design and engineering problems since the beginning. They recently announced a $1 billion charge as a result of problems, on this aircraft. And the initial schedule on this project is delayed by a year. Now, you say, okay, well, that's twice as good as the previous one, but you have to remember that this project isn't done yet. And unfortunately, project managers have a history also of concealing problems until as late as possible in the game, because they're hoping for a magic solution or something will start going their way and things will get better. So a lot of times they don't really own up until the project is done. On the previous aircraft, the 787, they came out one day, the CEO of the company came out one day and announced that the test flight was on schedule and everything was good. And the next day they came out and announced that, we, had to have an issue and flights are going to be delayed. So say, just because this has only slipped a year and only cost an additional $1 billion, I wouldn't count on that being it before the project is done. And the quote on the bottom of the page is from a aerospace analyst that says that this should have been a relatively simple project. Big, yes, but relatively simple, not out of the state of the art. Now, here's another example. This is a Congressional Visitor Center. This has been in the news quite a bit also. And it began in June 2000, and they said it'd be done in 2004, and they could do it for $265 million. Well, by the time it got done, 5 years behind schedule, it cost $621 million. And, you know, I can give you guys examples like this all day long. You know, this is just the tip of the iceberg. These are recent examples. Nothing here is old. Here's quotes from 1964. I'm a student of history. I think you can learn a lot from it. And the majority of these quotes came from a Apollo executives meeting. All of the presidents and vice presidents of all of the Saturn V contractors were at this meeting with Werner Braun Braun and all of the senior NASA management, and that's what the topic of the meeting was cost and schedule and budget and what can we do about it and what the issues are. And I have this document that is basically a transcript of the discussion of who said what, and that's where the majority of these quotes came from. And I see a lot of truth in them. I've been around, you know, construction and cost estimating for my entire life. And look at the first quote. I can think of a lot of programs in the Boeing company. If the estimate would have been realistic, you wouldn't have had the program. And that's what happens. You know, you basically build into the entire system a series of events that leads to underestimating the program. Now, the next quote didn't come from this aerospace executives meeting. It came from another a DOD document, a Harvard analysis. But basically, government agencies, and not only government agencies, big companies, they encourage contractors to submit, you know, optimistic numbers because they want to, you know, do something new and neat and cool. And, you know, the quote on the bottom of the page, we can give you the estimates all the way to the end of the program, but do you really want them? And, you know, these go back in history. There have been some quotes about some of the castles and the pharaohs and the cost estimates from that. But, I mean, this goes back. This is nothing new. And people always complain about cost estimating, but they never do anything about it. And, you know, why? If you're interested in this subject and you've never read this book, you might find it interesting. It's available on Amazon. It's paperback. It's relatively inexpensive. But basically, they looked at 258 large transportation projects. And what they found is this is projects that they could get data from, mainly public projects, and say, these are road projects, you know, rail projects, tunnel projects that are large, you know, public works projects. These aren't complex, complicated things. These are simple things. And basically, they found, you know, statistically significant findings that the cost underestimating cannot be explained by error. And basically, their quote is, it is best explained by strategic misrepresentation, namely lying, with a view to get projects started. And at NASA, they have the same issue. And the reason that the issue is with NASA is they pit one of the centers against the other centers. And the agency comes out and say, okay, centers, we're seeking new projects to go and do. So give us a description of your proposed project and an estimate and a schedule for this project. So if I'm a project manager and I come out and say, I want to go build a new Mars rover and it's going to cost $10 billion and take 10 years to do, well, then the other center comes out and says, well, I want to build a new Mars rover and it's going to take $1 billion and I can do it in 2 years, which project is management going to approve? They're going to approve the cheaper, sooner one. But, you know, the guy that puts the lower number out knows how the game is played. You put out the lower number, you get your project approved, you get your name in the paper, you get to go do cool stuff, and you know that when you run out of money, they'll give you more. And that's the same problem in industry. You know, they lie to the board of directors, they lie to whoever they have to lie to, or omit cost or exclude cost in the fine print that, you know, people that are reviewing don't really understand. They might see it, but they don't understand the implications of what's not included. And it all boils up to the perfect storm. And say, this is nothing new. This happens in industry, it happens in IT projects, it happens in construction, it happens in aerospace. It happens. And, you know, basically this study says that, hey, it's all a crock. Hey, Congress is, you know, jumps up and down and makes big speeches about, you know, cost overruns. But in reality, they say one thing, but actions speak louder than words. The new NASA administrator, one of the people that were proposed, some of the senators and congressmen didn't like him because he had a reputation of being a tough fiscal manager. And well, they say they want fiscal responsibility, but yet here is someone that if they did, that's who they would put into power as the new NASA administrator, but they didn't do it. So again, they're saying they want it, but actions are speaking louder than words. They're not doing it. Another example is Dick Cheney canceled the Marine Corps B-22 Osprey aircraft. Not one time, but 4 times. Why? Because Congress kept reversing the decision. And as far as I know, the project is still being built. Well, why did they reverse the decision? Because they want jobs in their district. They want the donations from the defense, you know, industry. You know, it's all about, you know, speeches and being able to go back home and say, I saved the aircraft and I saved this plant from being shut down. Well, would the plant be shut down? Maybe, maybe not. But irregardless, you know, the responsibility isn't there, and the actions are speaking louder than the words. Now, before I wrote this paper, I read, I kid you not, thousands and thousands and thousands of pages of documents and studies. And I sat down over my last year's vacation and read these documents. And I read them over probably about 3-week period, 7 days a week, 12 to 14 hours a day. And I kept seeing the same things cropping up over and over and over and over again. And, you know, every single project has an excuse of why they're different going in and how they're not going to be like the other projects and how they're going to do things differently and better. But in reality, we do things because there's a reason for doing them. And one of the reasons, you know, from my, you know, big long list is we exclude things. We exclude things that we will probably have to do, you know, from the estimate, you know, to keep the number lower. We exclude risk from the estimate. You know, every project, no matter what, has got risk. In the early phases of the project has got more risk because there's more unknowns. But if you look at the statistical analysis, the estimate confidence levels, they usually don't bear that risk out. And say their assumptions are very optimistic. They assume they're going to reuse stuff. They assume that, you know, this approval won't be a problem. They assume everything will be wonderful. And interestingly enough, one of the issues is absurdly low escalation projections. That's one of the things I study for my job is historical escalation rates. And one of the economy is cyclical. there are periods of low inflation and periods of high inflation. And so what happens is, over the past 20-year period of low inflation, that's all everyone has in their mind. They recognize that, okay, inflation's low, I'm only going to project low inflation. But part of what we're doing with NASA is we're projecting projects all the way to 2020, 2030, 2035, because we're planning a lunar exploration program, a Mars exploration program, and they're projecting numbers out tremendous difference. But they don't want to use real escalation numbers. Iran studies cited that's 11.2% reason for 11.2% of the cost growth in large plant construction. Another thing that I know that in the government arena people do a lot is they issue estimates in base year dollars. In other words, I'm giving you an estimate for a project that I'm going to plan on doing in 2020, and I give you the numbers in unescalated dollars. So I say, oh, well, it's only $1 billion. But if you add escalation on to 2020, it's going to be probably $2+ billion. But they do that to make the number sound as low as possible to get the project approved. But then in reality, what happens is you ultimately get compared to, well, you originally said it was going to cost $1 billion, and now it costs $3 billion because $2 billion was for escalation and another $1 billion was for change orders and unpriced scope that was required. So, but you get measured back to the $1 billion number even though you clearly said that it was in base year dollars. And that's one of the problems is you need to use realistic escalation, and that way if you do overrun, it doesn't look as extreme because it's not as extreme. And the sixth item is something that I see over and over and over again. Can't tell you how many estimates that I see that are not prepared by estimators. And you stop and think about it, everyone's an estimator. And one of the problems that I see, that the perception of, even if I am an estimator, that's my job, is estimating projects. And people expect an estimator to be an estimator, just like people that are not familiar with engineers think an engineer is an engineer. But in reality, there's not. There's a tremendous difference between a civil engineer and an electrical engineer. Even looking at an electrical engineer, there are electrical engineers that specialize in low voltage communications. There's electrical engineers that specialize in high voltage power transmission. And you take an electrical engineer that works on high voltage power transmission and you put him in charge of a communications, project, he's not going to succeed. So this is one of the problems, is that they go to an estimator that maybe doesn't have the qualifications or the experience, that's what they do, and that's what they get. And then a lot of times there's a lot of estimating certifications, and even though you're certified, that means you can pass a test. That doesn't mean you've had the experience and the qualifications and the experience to do, good quality estimates. And the seventh item is something that we do all the time. We reward failure and punish honesty. In other words, like the example I mentioned a minute ago, the honest estimator or project manager that said that my Mars science rover would cost $10 billion and take 10 years to do, well, my project doesn't get approved because it's too expensive. But my project manager that lied, that said the Mars Science Lab or the rover would cost $1 billion and I could get it done in 2 years or 5 years, my project gets approved because I know that I'll get more money when I run out of money down the road because they don't want to cancel the project. And the biggest problem that I see personally is they don't give you enough time to prepare a credible estimate. I mean, a real credible estimate takes a lot of time, and they get spent a lot of time is being spent just to put the estimates together. They're more worried about what color the money is or what bucket it is, or, well, what if we paint it green instead of red? You know, things that don't really matter on the total picture. But again, the quote at the bottom is from our president. It rejects a system that rewards failure and protects a person from his consequences. Again, actions are speaking louder than words. We're saying one thing, we're doing something different. Here is the escalation picture that I mentioned. What's shown here on the screen, the blue line, is the NASA New START Escalation Index. This is the index that NASA is, supposed to use in all of its escalation assumptions. And you can see the annual average there is 5%. And you can also see the cyclical nature of the economy. I don't know how many of you were around, but my parents built a house in the 70s or the 80s, and they got 10% fixed interest rate on a 30-year mortgage. And some people paid as much as 18%. Stop and think about it, where we're at now. And, just because we're low inflation and low escalation now doesn't mean that's necessarily going to continue forever. But what's in the little red box is the NASA official projections for what escalation will be in the future. And if you look at the numbers statistically, I put the numbers in at risk and did the best fit on the historical projection rates. And I look at a lot of other indexes also, all the way back to the 1900s and before. But using this data set, there's an 88% probability that the projected numbers will be exceeded. Well, you're crazy, because you got to remember escalation is compounded. And if you're low this year and low next year and low the year after, you're going to have issues. And, all of the stimulus money that's being spent, the free money supply, there is a probability, in my opinion, that escalation is, we're due for another period of high inflation. Now, I hope I'm wrong, but irregardless, to me, we should at least use our projections at the 50% probability rate. So there's a 50% we're high and 50% chance we're low. But this is only like the 20% probability rate. And, I think that's the wrong approach if we really want good, viable estimates. Here is some facts on the space shuttle that I did in some of my research. Congress was very, very concerned about the initial estimates. As a result, this program, the space shuttle program, was approved by one vote. The 1972 estimate was $5.5 billion. That had 20% contingency, so that was $6.6 billion. And according to the information I've seen, the contingency was promptly removed by Congress because they had a better way to spend it, because that was extra money. And the first manned spaceflight was projected in June 1976, which was 4 years later. In reality, it cost $17.7 billion and took 9 years to do. Now, people can't say they didn't know that, because there was an October 71 report that said that this is probably going to cost about $15 billion. But say, people hear what they want to hear. They want to do neat new stuff, and that's what they get. And so they can't say they didn't know. I found proof that they did know, but they choose to ignore it because that's not what they wanted to hear. And this is one of the reasons why the shuttle costs so much. The original concept was, hey, we're going to build a reusable aircraft, and it's going to fly up to space and fly back, and we're going to, put it in a big empty hangar, and we're going to load the new payload in it. We're going to, fuel it up and check the air in the tires, and then we're going to fly it again. So if I were to estimate the picture on the left, my estimate, even if I was dead on in the estimate for doing that, I would be wrong because that was not really what was required. And that's one of the problems is, you know, the assumptions are poor. Estimates are difficult enough anyway, even if you have good assumptions. But when you use bad assumptions, you're destined to get bad estimates. And it's exponential what happens. Now, this is NASA's way of dealing with this problem. And this is what initiative that Mike Griffin, our old administrator, started. And this is from Christopher Scalise. He was the acting administrator before we just got our new one. Testimony to Congress. It's basically they're going to require us to do what they call a joint confidence level estimate. And you say, what's joint confidence level? Basically, it is what is the probability that we can achieve our stated goals given our current schedule and budget. So this looks at schedule and estimate probabilities and comes up with a joint number. And there's lots of issues in calculating these numbers, but basically he's telling Congress that, hey, JCL will solve all of our problems. We'll be able to give you good estimates and good budgets, and we can be realistic, and you know, we have all this information for us. But in reality, I don't think it will. And here's an example that I found where we've tried probabilistic cost and scheduling previously. NASA's done it. DOD's done it. DOD is also pushing down this road. DOD is, you know, considering mandating the same requirement on their projects. But say if you've ever heard of PERT, this was a probabilistic scheduling concept, and this was done with great fanfare on the Polaris project. And basically, according to some research that I've done, it was actually a gimmick that they used to wow Congress. They flashed up all kinds of pretty charts and complicated terms and, you know, complicated math up on the screen, and, you know, got them to scratch their head and go off and leave them alone. Well, they've really got it going on. They understand it. But in reality, it didn't work. The same program, the same methodology was used to manage the Trident program, which was, you know, nicknamed the single worst managed project in U.S. military history. But say it didn't work. Why didn't it work? Because it ignored the possibility of unlikely events. You know, people say, well, what's the probability that, you know, escalation will be 20% next year? Well, it's low, but you can't say that it's impossible. You know, and things stack up, especially the longer the project and the more expensive the project. According to my research, the more likely it is to overrun. And then there's a number of reasons for that, and I'm just touching on them here and there, but in reality, I could talk to you for an hour on almost every one of these slides in more detail than you probably want to hear. But there are reasons why, you know, this doesn't work. And we're going down the same path in the future. Now, this is, from what I can dig up, the real reason why the program worked. And probably the very top reason there is they attracted top talent. And they were limited to what they could pay them because, you know, the military, the pay is limited, you know, it has to be equal and this, that, and the other. So they gave them all kinds of special privileges, special uniforms, first-class travel, which back when this project was done, first-class travel was special. That was really something. And they did not tolerate failure. If you failed or lied, you were dismissed within 24 hours if you were a government employee. Contractor personnel, they couldn't fire them because they didn't work for them technically, but they, you know, got it in their contract that they were not allowed to return to their previous assignment. It was an interesting deal, and there is a book on this topic, the Polaris System Development, that's very, very interesting if you like this kind of thing. They actually required contractors not just the contractors, but the contractors' personnel that would be working on the project. They required them to sign a personal pledge that they could and would meet the schedules. I mean, it was a truly innovative concept that they went with. They didn't require numerous paperwork and, reports and that kind of thing. They wanted them to spend their time doing the work. And I think that's one of the problems that we have, is that every time we have a project run over or a schedule slip, we initiate a new requirement that requires more paperwork and more people to process the paperwork and more reviews of that paperwork, and you're spending less and less time managing the project. But this is being forced because all the project managers are lying, but the project managers are lying because they're rewarded for lying. I mean, it's a vicious circle that goes on and on and on again. But one thing that they did not tolerate was lying. And if you lied, you were gone. And they also kept numerous paths open to them. They wouldn't just pick a road and go down it. They would pick 3 roads and go down it until they were convinced that they were on the right one. Every major decision, was treated this way. It was a truly an amazing project. This was a very complex, big development project. It required lots of innovations, lots of new technology, and they did it on time and on budget. This is a recent NASA project. This is for the stereo mission. And the red S-curve on the left is the original project estimate and S-curve. This is for cost only. This is the percent probability on the left and the cost on the bottom. So basically you could go up and say there's a 50% probability that this project will cost about $275 million. That I can get the project done, for $275 million. But they bumped it up to a 70% probability, so they gave him $299 million. And, that included a 20% reserve. But that was the S-curve of the project. So you think maximum, the worst it could possibly be would be about $375 million. I'm got 100% confidence it can't exceed that. Well, what happened? The final cost was $551 million. Well, why was that? And this curve that you see, one of the ways that NASA estimates how much these missions cost is they have parametric models, and they feed in all of the historical data of how much this mission cost and how much it weighed and what was the weights and the power requirements and the size, and they have all these inputs in it. How much of the hardware and the sensors are going to be reused? They call it heritage. How much is heritage equipment? So they take this equipment and say, okay, this is heritage equipment and it's been used on another mission, therefore I don't have to pay to design it. And I know how much its power is going to be, and there's very little uncertainty around that. So that S-curve for that project is pretty vertical, and there's a pretty low amount of risk on the project. Well, what happened, that blue line, is after the project was done to prove a point, David Bearden, Claude Freener, and some people from Aerospace Corporation, they used the same model, and they input the actual data for the project. In other words, how much into these same parametric, cost models, how much was new, how much was reused, what was, really the known and that kind of thing. And they came up with basically exactly what the number should have been, fell in the middle of the curve. So it all goes back to our assumptions, what we assume early on in the project. This is how the English government deals with bad estimates. Is anybody walks up to them and tells them they've got a new project they want to go do, they look at the project, and if they want to approve the project, they will automatically add schedule and cost to the numbers, automatically. And this is outlined in the Green Book, and they're available on the web. There's several volumes and supplementary volumes if you're interested in it. just do a Google search on it. But so they split the projects up into different kinds of projects because they recognize that some projects have more risk than other projects. So for duration and cost. So say this is, you know, a snapshot taken from their document just to kind of give you an idea of how some people are doing it. This is also big in Australia. These are some possible solutions that I come up with. And basically the top one is you hold the project managers accountable to the estimate. And they always say they're going to do that. But in reality, they never do. Now, this time's going to be different. This time's going to be better. This is not the same as before. We're smarter now, but we're not. We keep doing the same thing over and over again. What's the result? What's the old adage? The definition of insanity is keep doing the same thing the same way and expecting different results. Well, that's what we're doing. If you hold them accountable and truly hold them accountable, they will start demanding good estimates. Right now, they don't want good estimates. They don't want to know the truth. So they get a low ball estimate. They get the project approved. They justify the cost increases with, you know, new scope. Well, in reality, a lot of times it's not new scope, or there's one or two new scope things, but in reality, it's usually things that were omitted, or it's things that, you know, it's, you know, one part was omitted and 9/10 were make themselves whole. Here are some examples from NASA's past. The original space station was designed with 8 functions. It was supposed to support 8 functions in space, but because of cost overruns, they cut it down to 1. Still had cost overruns, but they only got 1 main function from it, but originally designed to 8. The space station, the space shuttle, its original requirement was for a payload capacity of 65,000 pounds. But in reality, the maximum current payload capability is 49,000 pounds. And this is one of the things that is done to cut cost, because they couldn't get any more money. So what did? They cut costs. They made the vehicle a little heavier because lightweight costs money in aircraft. The Mercury program, they deleted 2 monkey passenger test flights. Why? To maintain schedule. You know, it goes on and on and on. If you really look, the excuse is always scope growth. But in reality, the requirements a lot of times are trimmed in the things that the new scope is really things that should have been in the original estimate but were excluded to keep the number low and to get the project approved. Now, in reality, what you should do is include, when you're doing your probabilistic cost and schedule projections, is include all possible risk. Okay, there's a 1% chance that this thing's going to, you know, something bad is going to happen. If you've got 100 risks with a 1% chance, you've got a 100% chance that one of them's going to happen. And if that one risk has got a high, you know, impact on your project and you don't account for it, you've got a problem. And another problem that the government agencies have is we get yelled at if we don't spend all of our money. So in reality, you can't underspend on one project and take the spending, the savings from that project and put them on another project, because that's a no-no. Everything has got colors of money. Everything has got buckets. Everything it has to be segregated. You can't take construction money from one project and put it on another project. You can't take money from one division and put it into another one. Not without special approval and lots of paperwork and lots of hassle and lots of issues. So what happens is, and it's the same thing that happens on a lot of military bases, I used to do a lot of defense work, is the military bases get a jet fuel allocation for the year. And if they don't spend all of their allocation for the year, if they don't use it all, their allocation for the next year gets cut. So what do? They make sure they use all their jet fuel. And back in years past, that meant dumping it out in the back someplace and setting it on fire, or spending lots of time on training flights that weren't required, whatever it took to get rid of their fuel so they would get their full allocation next year. because next year we may be fighting a war and we may need it, or we may have some new mission, and you can't get increases, so they have to make sure they use it all. And this is one of our problems. And I know this isn't as much of an issue as in private companies, but that's one of the problems with the government, projects. And this is something that we often exclude in our analysis is external factors. Well, we can't control it. There's nothing we can do about it, so why account for it? But according to some analysis that the GAO did for us, the Government Accounting Office, is that out of the 10 projects, about half exceeded their cost and schedule as a result of external factors. So if it's something that's going to affect your cost and schedule, you need to budget for it. If you don't, you're destined to failure before you get started. This is something else that kills me. We rename projects and rebaseline projects, and then if we underrun the rebaseline project, we claim that we came in under budget. But in reality, we don't. The top project, the initial baseline approval estimate was $472 million. When the project got done, it was $712 million. And I saw another report that says it was $800 and something million. Got to remember, real numbers for a lot of these projects are really difficult to get your hands on, because a lot of times when one project starts running over, they start charging to another project. And that makes it even more difficult to really, wrap your hands around the problem of what's going on. But they rebaseline, and then when I can bet your bottom dollar, whenever they went in for approval for the $712 million budget, they said, well, our previous, baseline estimate was $669 million, and now we only need $712 million, and then we can get everything done. You can guarantee they didn't say, well, our original estimate was $472 million, and we really screwed up, and now we got to have $712. No, they incrementally increased their budget. And then if they came in for $711 million, they would claim success and say, look how great we are. But this is what happens. And this is just a short list that was something that I could put on a PowerPoint and blow up big enough for you to see it. It goes on and on and on. Here's a statistic that I found. 58% of DoD projects are rebaselined. The V-22 Osprey aircraft that I mentioned that Dick Cheney canceled 4 times was rebaselined 10 times. The F-22 aircraft was rebaselined 14 times. So it just keeps going on, but this is all part of the game. They're playing the game and wondering why they're getting cost overruns. This is NASA's actual cost history, the best I can determine on 96 projects. This is the first available cost estimate to the last available. It may not be the last estimate or the first estimate. It was just the first one I could get my hands on and the last ones I could get my hands on. Most of these are spacecraft projects. But what's the common trend there? Is virtually they all overran. There's only a 12.5% chance of completing one of these projects on or under budget. The average growth, the cost growth is 93%, and the median is 51%. In reality, if these overruns are consistent, you can predict them. So why don't you? Why don't we? And in reality, this is probably low as a result of some of the rebaselining activities that I'm talking about. And also, some of these projects were canceled. They were never done. If they were really, all completed, a lot of them were canceled for cost growth reasons and schedule growth reasons. Well, if they would have been completed, the cost would have been, kept increasing. So these numbers would even be worse. Now, one thing that you do, this is admittedly a simplified approach. You have to be careful of, something they call Simpson's paradox. And if you're not aware of that, generally, everybody understands the larger your data set, the more reliable your conclusions are. But you have to make sure you're measuring apples to apples. In other words, if I'm trying to figure out how long it's going to take me to run a marathon, how long it takes someone to run a 100-meter dash, doesn't, it has no relevance, does it? You know, you only need to compare like projects because every kind of project has unique sets of issues and risk and probabilities. So, you know, say if you're trying to measure the risk of an IT project, you don't want to look at a risk on a road construction project because they're not the same. You will get bad results. However, if you've got historical data for 10 IT projects that are comparable to what you're doing, you can use those to measure the risk for your new IT project. But this is just something to be aware of. You have to be careful with using historical information to make inferences, or you will get the wrong result. But using the chart that I showed you a minute ago, this chart, using that distribution that I generated from that risk, I calculated, developed this method of projecting what the project would, really cost. So what this says is when somebody walks up to me and says, hey, I've got a brand new project that I want to go do, and I think it'll cost $1 billion. Well, this tells me that in reality, if this project is going to cost $1 billion, to get a 50% probability, it's really going to cost $1.6 billion. And if I want a 98% probability, it's going to cost me $5 billion. This is a way to add just something they call a fat tail to your project. It adds a fat tail to the right side of your project, and it imparts risk for those things that maybe you're not being honest about, things you don't fully understand, or risks that are out there that you're not aware of yet. So this is something that I, suggested to NASA that they use, and they haven't started doing it yet, but that's, say this is my suggestion to it. And this is just an overview. This chart shows the multiplication factor of that. And here shows an S-curve, a cumulative S-curve of that. So basically, if you've got a $1 million point project, they're saying that, hey, there is a small probability you can get it done for your $1 million. And as the project progresses to 50% complete, well, then there's a greater percent probability that I can get it done for the $1 million, but I still have a lot of risk out there. And as the project completes to 75% chance, well, then there's an even greater chance that I can get it done for it, assuming my $1 million estimate is still holding true and there has been no cost and schedule growth, which, as we've seen, is highly unlikely. So in reality, if I started out with $1 million and when I got to 50%, my number was then $1.5 million, you would run the same calculation and you would get a same fat tail because the project wasn't done yet. This is just mainly done for illustrative purposes to show how that affects your results. And this is the results for a hypothetical project that basically says, okay, I've got a project that's got a little bit of risk, that I'm willing to acknowledge. So I'm taking that little bit of risk and those distributions that I'm willing to acknowledge, I'm adding on a historical risk distribution to give me a fat tail. And as the project progresses, I'm removing, progresses to completion, I'm removing the amount of, fat tail that I'm adding to the project, and the project's, tendency to recognize risk as the project progresses, it skews the tail over automatically by itself until the project is 100% complete, and then you have no risk left, which really when it's 100% complete, your S-curve should be straight up and down, but this is mainly to imply like when you're at 99.99% complete and there's still something that could happen, some lawsuit, some issue that's still outstanding. Basically, this is how it works, is you have your historical risk distribution, you have a binomial distribution, which is a discrete risk deal, and your historical risk. And you build the table and you say, hey, my project is at 0% complete. That means there's 100% remaining, and it enters that data in and gives you those fat tails. And I know this is kind of a, brief description of it, but I could talk about this for an hour and we wouldn't get done. So if you are interested, this method, this paper that I wrote is 109 pages. It is available online, and at the end of the presentation, I'll tell you where you can get it if you're interested. But say it's something that I use if I truly want to understand what the probable risks are for a project, and it's very simple to do, assuming you have historical information on your projects. Here's an example of a $1 million probabilistic project. So basically the status quo, remember the stereo mission chart that I showed you, would be the blue line, how we normally do business. Yeah, we can do this for $1 billion, there's very little risk. But in reality is more like the red line, which is a project with 25%, in the fat tail that this method adds to your project. And you can do the same thing. I'm showing, this is demonstrated with cost. I do the same exact thing with schedule, because in reality they're related. You need a different distribution because they're not the same, but you can use the same methods to calculate your schedule probabilities as well. Now, these are just some of the conclusions, and say most, as you've seen, most large projects grow in cost and schedule. And it's not unique to the DoD or the government. Every project, every large project I've seen has these issues. Almost every single early estimate is fairly optimistic, and any early joint confidence level estimate for a development project that has an S-curve that doesn't consider the possibility of triple-digit growth is ludicrous. It's not real. It's just not real. Somebody is lying to you, which, as you've seen, is very common in these kind of things. And basically, we need better estimates by real estimators, people that are experienced in the kind of work that you're doing. And on some large projects, one estimator will not have the information and the knowledge and the background of, what it really takes. And you may need a team of estimators that are really honest and diligent. And estimators are typically an overhead item. And when the economy slows down, they're usually one of the first things that get cut, because you have all of their data and their archives that other non-estimators can use to estimate your projects. But usually that's only good for so long, and then you start running into problems because you don't have an estimator. Hold your project managers accountable. If you hold them accountable, really accountable, they will start demanding good estimates. They will stop skewing the numbers, and your problem will be solved. Say your actions speak louder than your words. I've got an example. Here at NASA, they have a project that is a safety project. It is a emergency egress system for the astronauts. And our life safety office is basically demanding that we increase the cost of that project by about 50% to get another 0.0005% probability that of safety for the astronauts. 0.0005%. But in reality, if I bring up a cost, risk or a schedule risk that's less than a 10 or 20% risk, they don't even want to hear it. But that's my point. They take safety risk very, very seriously. Cost risk, they don't. Schedule risk, they don't. Actions speak louder than words. They're saying they want good numbers and good schedules, but yet their actions are not supporting that assertion. The paper that I mentioned, it has a lot of this data in it, and more details on how to run the model and set it up and everything, is called the Joint Confidence Level Paradox: A History of Denial. It's available online at several websites. Just Google it. It's free. There's no cost to it or whatever. Just download it and thumb through it, and hopefully you'll get some insight into it. I've got one last chart here that I was told was a true story. I was told this story by one of my former bosses that worked for the NSA. And basically, the first line obviously is mine, you know. Saying there will be no more cost and schedule overruns can be compared to saying there will be no more drugs in this country. This is the true story part I was told. Now, it sounds impossible, doesn't it? Can you imagine what would happen if Barack Obama got on national TV tomorrow night or tonight and said there will be no more drugs in this country? Everyone will say, yeah, right. Well, a dictator of a small country appears on national TV and says there will be no more drugs in this country. Oh, why did he say that? Because it was a small country that the USA had a number of military troops in that got a large amount of government, you know, financial aid, and say, I have no quantification that this is true. This is just what I was told of what happened in the 70s. You know, everyone laughed, just like Obama. You know, everyone laughed at President Obama if he said it, and said that's impossible. But the USA told this dictator, hey, all of our soldiers, when they come to your country, are getting hooked on drugs and having problems, and this isn't good, and you better do something about it or we're going to cut your aid. So by God, he did something about it. The next night, same dictator got back on national TV, lined up 24 people and shot them with a machine gun. Says, these people were caught with drugs. This happened every night for the next 2 weeks with reductions in the number, you know, every night of the people that were shot. Before long, there were no drugs available. All the rehab centers filled up, you know, and basically, you know, the point of this whole story is before things change, the approach and the consequences have to change. You can't say that this time's going to be different, this time's going to be better, this time we're smarter. If you don't change the approach and the solution, you know, the solution isn't going to get any different. So that's basically what I have prepared.
Glenn, that was great. I think this is an exciting topic, and I hope it permeates through all kinds of different businesses. There's a clamoring already for the slideshow of this presentation. Is that something you'd be willing to give out?
Absolutely.
Okay, good. Because I'll send that out in my when I send the information about the recording link to everybody who's here. I'll send that out along with it. If that's no trouble, you can just send that to me. Let's see if we have some questions. I think we do. We've got. Oh, there's one question here. I'm not quite sure I understand it, but I'm just going to read it.
Okay.
For the FY 1972, why was 20% used for the contingency in regards to the space shuttle?
I honestly do not know the answer. All I can say is that I read every historical document that I could get my hands on. I read some of the presidential memos. I read memos from the, the OMB director to the White House. That was just the number that they decided to use. And, you know, one other interesting thing, talking about historical projects, the original Apollo program estimate done in 1958 was for $1.5 billion. The original NASA estimate was $7 billion because NASA was only created in 1958. Then the numbers got bumped up and padded a little bit to $10 to $12 billion. But then the administrator at the time placed an administrator's discount on NASA's ability to estimate the cost, and he overnight padded the numbers to $20 billion, and the final cost for the project were between $20 and $25 billion, depending upon what you include and what you exclude. So that this goes to show you back then, the Apollo program is held up as a success because they didn't have these huge cost overruns, but in reality, it depends on where you measure the cost overruns from.
Okay. See if we have any more questions. You can just type them in your chat feature, or you can use the Q&A panel also. think there's a lot of great interest in this. Such concrete examples that are people like me are certainly interested in.
Firm examples are very difficult to get your hands around because people are embarrassed by this. They try to, you know, revisionist history, and they try to bury the facts, and I can't tell you how much work I have to go through to dig up some of the examples that I've used in the paper. I mean, it's hours and hours and hours of research, but in reality, that's what it really takes. If you don't recognize the problem, you'll never change it.
Exactly. We kind of feel, you know, following the media and everything, that maybe things are changing for the in a positive direction. So that's good. Some exciting projects coming up, and we know they're always going to cost some money. Well,
Absolutely.
Let's see, do we have any more questions, folks? Or I think the recording of this will be archived, and if you happen to be watching it then and have any questions, you can just email me at jromeo-hall@palisade.com, and I'll forward them to Glenn, because he and I will be in touch. And I'd like to thank everybody for coming, and thank you very much, Glenn.
No problem. Thanks for having me.
Maybe you'll be able to come back sometime, and we can do this again. We can pick it up again, see how things are going.
Sure.
Great. Oh, wait, maybe I do have a question here. Oh, there's another further good examples of project cost issue can be found in Mega Projects and Risk by Fly-Jerd, particularly for transportation.
That's the book I was talking about.
Right. Good. Oh, good. And a friend of ours from New Zealand mentioned that. And so that, I just wanted to say to our friend, that's actually what we were talking about. So that's good.
Yeah, that's on chart 9. Maybe they joined late or whatever, but that's on chart 9, that, you know, what we were talking about, the 258 large transportation projects.
That's exactly right, because he got up at 4 a.m. his time for this. So.
Ooh.
It's just, yeah. And let's see. I have any. That's it. If I've missed you and you still have a question, just feel free to email me and we'll take care of it. And I'd like to thank everybody for coming. Great. Thanks, Glenn.
No problem. I'll email you the presentation.
Okay, thank you.
All right, bye-bye.
Thank you, everybody. Bye-bye.